All right, so problem 122, best time to buy and sell stock 2. This problem, trash problem, okay? The question makes no sense at all, and I'm going to explain it real quick. So say you have an array of prices for which the ith element as the price of a given stock on day I. So we have an input here. Each number, well, each indice is a day, but the value at the indice is the price for the stock that day. Design an algorithm to find the maximum profit. You may complete as many transactions as you would like. Buy one, sell one share stock. Buy one and sell one share of the stock multiple times. Note, you may not engage in multiple transactions at the same time. You must sell the stock before you buy it again. So this problem, if you check the comments, there's a lot of contentions. Okay, so basically, you want to read the problem very closely here. So say you have an array of prices for which the ith element of the price of the given stock on day I. Design an algorithm to find the maximum profit. So you want to just stop right there. This other stuff after here is just going to mislead you. So you want to design an algorithm to find the max profit. And so one way to do that, to save the headache, you might think, oh, we have to create some kind of like recursive or iterative algorithm, and we're going to buy a stock on, let's say, the first day. Then we have to say, can we make money on this stock the next day if we sell it? And if we continue with that pattern, we already bought the first stock. What if we buy again on the third day? And you can do this in like n to the n time, I think, with a bunch of recursion, but it gets really complicated really quickly. So a quick way to actually solve the problem is if we open up this right here. So this is a graph of this data right here. So this approach is called the peak valley approach. So if you take a close look, this data here is this data here. So at the first index, okay, well, it's the same data, but it's moved over, or actually it's a little bit different, but same idea here. So at the first index, the day 1, price of the stock is worth $1, or whatever the unit is. Second day, it's worth 7. Third day, it's worth 3, and so on and so forth. So with the peak valley approach, what we can do is we can define what profit means. So if you take a look at this graph here, to make money, if we buy stock for 1 unit here and we sell it for 7, then we make a profit of 6. So we can define profit as going from a low point to a high point. And the difference of going from the low point to the high point, so the high point minus the low point, is what profit is. So if we take 7, which is the price at day 2, minus 1, which is the price we bought it at, you get 6 units of profit. So looking at it this way, what we can see is that the problem asks you to design an algorithm to find the maximum profit. So if we defined profit as the lowest, as going from a low point to a high point, whereas losing would be called going from a high point to a low point, if the algorithm says to design a maximum profit, what we can do is just sum up the differences of all the points of the differences that go from low point to a high point, and then sum the differences of the high point minus low point. So to get the solution here, you could do this. So going from 1 to 7, this is where we make money. We do 7 minus 1, that's profit 6. We can't do anything here because we're losing money here, right? So the maximum profit that could be made, if we add this to our sum, then we're losing money. That's not the goal here. The goal is to find the maximum profit. So what we can do is you can consider this one. So this is where it's conveniently labeled A. So we go from 3 to 4, that's going up. We do 4 minus 3, that's 1 unit of profit. And then so on and so forth, C minus B, 6 minus 5, it's not really labeled here. And so on and so forth. We don't want to include this point right here because, as we mentioned before, going from a high point to a low point is losing money. So conversely, what we could do to find maximum losses would be to sum the differences of going from a high point to a low point. And so that's kind of how you can kind of visualize this problem. So we said, let's define profit. It's going from low point to a high point. Once we find this point, profit is defined as difference between high point minus low point. So we said, how do we find profit? Low to high point. When we do find the profit, what's the value? Profit is equal to the high point minus the low point. And so we can kind of take this greedy approach and just extrapolate it to the whole graph. So we can just iterate through. We're going to need max profit here is going to be equal to 0 because we're starting at 0 for our maximum profit. We can do for price, or not even that. We want to, since we're going to be adding, or we're going to be checking to see if we can define something as profit, we need to do this with indices. So we can do for I in range len of prices. And then, like we said, we just want to sum the differences of all of the points where we make money. And we say, well, how do we find profit? We have to find where we're going from a low point to a high point. Well, how do we do that? We can check if prices sub I is less than prices sub I plus 1. Because we said that this is basically literally what we're checking here. We said that we're going to check if we're going from a low point to a high point. And this says if price is I, which is the first point that we're at, the current point that we're at is less than I plus 1, which is here, then we know we found a point where profit can be evaluated. And then we said, well, how do we evaluate profit? We said that profit was equal to high point minus the low point. And we know that the high point is prices I plus 1. And we know that the low point is prices sub I because we said we're going from low to high. So if we wanted to do the difference, we would just do high minus low. And then we can do max profit plus equal profit. And you can condense this into one line, but it's just to make it a little bit easier to understand. And then we can return max profit. So we can submit, first time doing this problem, by the way. This problem took me like 3 hours, I'm not going to lie. Prices sub I, invalid syntax. For I in range. Something's messed up here. I forgot a colon. I don't use this language, boys. List index is out of range. I plus 1. List index is out of range. I think we might have to do something slightly before the end since we're checking. Oh yeah, okay, there we go. So since we're checking the first one and the second one, then we want to iterate right before the last one, of course. That was my bad. And so we'll see here that we get faster than most of the solutions, but this really depends on how many people are running code at the time. But that's a really simple and quick and easy way to see how to make this work. So the main problem with this question is that it's a simple question, but the way that it is, the way that it's phrased makes it really difficult to understand. So we just want maximum profit. We define profit, and then we sum all the profits that we can see, and that'll be the maximum profit. Conversely, we could sum the points we're going from high to low, and we get the maximum loss that we could, if that was something you wanted to do. So that's 122.